So this lesson is going to be on solving quadratic equations by factoring. We're also going to see some third degree functions as well, or third degree equations. And so just keep that in mind as we push through here. We're going to get that as well. So without further ado, let's talk about real numbers here. So real numbers. So real numbers fall into two categories. They're going to fall under the category of rational or irrational numbers. So rational numbers, we've talked about, whole numbers are rational because they can be expressed as fractions. Integers, which we start to talk about those negative whole numbers as well, they'll also fall into the category of fractions. And of course, as I said, any number that is a fraction is a rational number. And don't forget, decimals that are terminating or repeating can also fall under the category of rational numbers. Irrational numbers are going to take on the look of numbers that have this kind of look, like pi, or if you start to see this radical symbol, this is actually the square root symbol, but the symbol itself is radical. There's supposed to be the 2 there, but over the years they dropped it. And then here we have what's called the cube root of 12. These would be examples of what we call rational numbers, because when you turn them into decimals, the decimals do not repeat or terminate. Something else, with respect to these radicals, remember on your calculator, you'll see the plus sign, and above the plus sign will be the minus sign. Above the multiplication symbol, you'll see the division symbol. Above the x squared button, you should see this square root button. That's where that comes into play, because it's the inverse of squaring. So remember, 5 squared is 25. So if I go backwards, if I go the other direction, if I start with the 25 and go this way, that actually stands for the square root of 25. So the square root of 25, what it does, it gets you back to the beginning, which is what was actually squared that gave you 25. That would have been 5. So square root means you're looking for that original number that was squared that gave you that. So if you know that 2 cubed is 8, then you can go backwards and say the cube root of 8. If you go backwards this direction, you now can use the cube root symbol and say the cube root of 8, and that's going to give you 2, because that's what actually was cubed that gave you the 8. So 3 to the 4th we know is 81, because 3 times 3 times 3 times 3 kind of means 9 times 9, which is 81. So 3 to the 4th is 81. So this is the 4th root symbol. And if you take the 4th root of 81, that's going to take you back to the 3. All those symbols can be found in the calculator. We'll talk more about that as we move more into using the calculator. Something else we come across in math is what's called the multiplication property of 0. When you multiply by 0, the answer is always 0. So what we say then is this: if 0 is one of the factors, then the answer, in other words, the product, will always be 0. So if we have like a times b is equal to 0, the only way this can hold true to get a 0 as an answer, as the product, either a has to equal, excuse me here, my thing just went crazy on me. So a has to equal 0, or b has to equal 0 for that to hold true. So if one of the factors is equal to 0, then the answer itself has to be 0. So as we move into the another topic to kind of bring to your attention, and that is let's see here, the number of possible solutions to an equation. It's going to be indicated by the highest degree term. So last time we were dealing with first degree equations, in other words, linear equations. Linear equations, they're not going to have more than one solution since the degree is 1. So now we're going to move into what we call quadratic, which means there's an exponent of 2 in the problems. If there's a second degree term, then there's going to be there's going to be no more than two solutions. So we're going to be looking for at least two solutions in some way, but no more than two. Okay, so sometimes the solution will be the same answer though, so it kind of represents just one. We'll see that more as we get into this. A third degree or cubic equation, again, it's going to have no more than three solutions. As we move forward, a lot of times I'll be using the word roots and zeros instead of solutions. So when we start to solve quadratic equations, sometimes we'll say, hey, find the roots to the equation. And since it's quadratic, we're going to be looking for two roots or two zeros, if you will. So in this lesson, we're going to be solving quadratic equations by factoring. So for this to work, for factoring to work, the equation must be represented in the form ax squared plus bx plus c is equal to 0. So for quadratic equations, there has to be a quadratic term, the x squared term. The linear term and the constant don't have to be there, but I think ours will. But this equation also has to equal 0. So usually you're going to see the quadratic term, the x squared term, the linear term, the bx term, and then c, of course, is the constant. So as we move forward, we're going to take note that in this, x is the variable, and a, b, and c will be some type of number. So again, we're going to be taking advantage of the multiplication property of 0. A times b is equal to 0. And again, what this means is a is going to be a factor, a is going to be a factor, and b is going to be a factor. So what that means is, as we move forward, we're going to be, again, factoring expressions. So let's see if we can find the roots of the following equations. So again, we want to find the solutions. So remember, in factoring, one of the first examples they usually give you is just find the GCF. So if I look at these two terms, we kind of see that we have this x squared term and this 5x term. What we're trying to do is identify a common factor, preferably the greatest common factor. So notice how they both have an x in common. So I'm allowed to factor an x out and then put the remaining factors in the parentheses. So since I brought an x out, that leaves me an x. And since I brought the x out here, that leaves me the 5. So we have the expression x times the quantity x plus 5, and that's now in factored form. Once it's factored, what we do is we set each factor equal to 0. So we're going to set x equal to 0, and we're going to set x plus 5 equal to 0. And we're going to just solve these two equations. Notice how x equals 0 is already solved. To solve the second one, if you want, you can use the property of equality. Since I have a 5 here, I need to use a negative 5 on both sides. And when we simplify that down, we get x by itself, x equals negative 5. Also note that just by looking at it, if you have a 5, I need a negative 5 to make a 0. So if I can just see the answer, I can just write the answer down without using the property of equality. So the solutions would be then these two solutions. As we said, a quadratic can have at least two solutions. I'm sorry, no more than two solutions. And so we did find two solutions there. So if we look at this equation, we have 3x squared plus 14x minus 49 equals 0. Again, we want to find the roots to this equation. First off, again, notice that it is a quadratic equation. So we want to do some factoring on this. I'm going to use big T, or 4 square and big T, to solve this, and because notice how there's a 3 as a leading coefficient. These can be tricky to factor. I think 4 squares can sometimes give us a strategy to solve these things. So if I can get this to work for me. Let's see here. So I'm going to try to draw my 4 square. Okay. Now remember when you use 4 square in big T, the upper left-hand corner in 4 square is the quadratic term. The bottom right-hand corner is the constant. And we have to multiply 3 times negative 49 to get that answer. So what is 49 times 3? I don't have my calculator next to me. So 27. That's going to be, looks like 147. So when I use big T, notice how this is not favorable for big T actually either, because you have this negative 147 in there, and we have to have then this 14 as well. So the factors of 47, of course, 1 and 47, but that doesn't look like there's any way in the world that's going to give me a 14. 2 is not going to work since 147 is odd. 3, I'm not sure about 3. So let's see if we can find a calculator here real quick. Just some technical difficulties here. So let's see if we can put that in the calculator here. So 147 divided by 3, that's actually 49. So 3 does go there. And again, 3 and 49, I don't see any way, shape, or form that they're going to somehow give me this 14. Since 2 doesn't work, 4 doesn't work. 5 won't work because it doesn't end in a 0 or 5. 6 doesn't work because 2 and 4 don't work. Now we're down to 7. So 147 divided by 7, that's going to be 21. So 7 and 21. That looks like it's got some potential. So what I pick up on is I probably need a negative 7 because I need a negative number. Negative 7 times 21 does give me this negative 147. And negative 7 plus 21 does give me this 14. So I'm going to rewrite then the linear term using negative 7x and 21x. So now I built the inside using 4 square. And then since there is a coefficient here, we do want to factor out the GCF first. And the GCF would be x. And then x times what would give me 3x squared? I would need a 3x there. I need a negative 7 here. 7 times 3x is 21x. And 7 times negative 7 does give me this negative 49. So this does factor then into 3x minus 7 times then this x plus 7. And that's going to equal this 0. Now, since it's factored, as I said, when you multiply the leading coefficient of the constant, we got this negative 147. And we had to add it up to get this linear coefficient, which is this 14. And big T kind of helps us organize that. So now that we factored it, we now want to set these two equations equal to 0. So 3x minus 7 is equal to 0, and x plus 7 is equal to 0. The x plus 7 equals 0, that one's pretty obvious that the answer should just be negative 7 because negative 7 plus 7 is 0. This one's not as obvious. So using the property of equality, we go after the 0 pair, add the 7 on each side. That gives us then this 3x equals 7. Then we have to divide by the coefficient. So if we divide by 3 and divide by 3, we see then x equals 7/3. So my solutions would be then the 7/3 since it doesn't reduce, and negative 7. So again, a quadratic can't have no more than 2 solutions, and we found those 2. So when I come to this problem, I have 6t squared minus 42t plus 72 is equal to 0. Again, notice the calculators start to come in handy here. So notice how I'm hoping 6 is a GCF of each one of those terms. So if you want test 42 divided by 6, we do see that that's going to be a 7. And 72 divided by 6 would be a 12. So again, my GCF is going to be a 6 because it goes into the 42 and the 72. So I pull out the 6, that leaves me a t squared. That's going to give me a minus 7t, and then that's going to be a plus 12. It's going to equal then 0. So to factor a trinomial that looks like this, since there's not a coefficient in front of the quadratic term, we know that all I got to do is set up two sets of parentheses. All I need to do is put a t here and a t here because t times t is the only way to get the t squared. But the catch is I need to get this 12. So I need to use big T. What are the factors of 12 that are going to add up to this negative 7? So 1 and 12, 2 and 6, 3 and 4. And since I need a negative 7, I need those to be both negative. And a negative times negative does give me a positive 12, so those do play out to be correct. So that means I can finish this off with a minus 3 and a minus 4, and that would be my factorization. Now we just set each individual factor equals 0, so I have 6 equals 0. Well, 6 does not equal 0, so we just throw that out. So now we're just down to t minus 3 is equal to 0, and t minus 4 is equal to 0. And we know that 3 minus 3 is 0, so t has to equal 3. And 4 minus 4 is equal to 0, so the solution there would have to be a 4. So that would be my two solutions, or again, our roots. And solving this quadratic equation, because again, I see the quadratic term, it still has to be set equal to 0. So by getting rid of the negative 56 with the positive 56, I can add that to both sides. But notice how it's not a like term to those two. So I just kind of offset it just a little bit. So remember, when we bring this down, we want it to be from the quadratic term to the linear term to the constant. So the correct order there would be then this x squared plus this 15x plus this 56 is equal to 0. Now, if you're pretty good with your math facts, what you're basically looking at then here is, since the coefficient of the quadratic term is 1, all you got to do is just put x times x here. What it boils down to is, what are the factors of 56 that add up to a 15? And most of the time, it's the more common factors. What I think of a 56 is I think of 8 times 7. 8 times 7 does give me 56, and 8 plus 7 is 15. So I'm just going to kind of go straight there. I don't have to necessarily list out the factor pairs if I can kind of see it. So that passes both tests. So I can put a plus 8 here and a plus 7 here. And now it's factored. And since it's factored, we now can set each factor equal to 0. So x plus 8 equals 0. X plus 7 is equal to 0. And notice that to get this to be 0, we just need x to be negative 8, because negative 8 plus 8 is 0, so that would be that solution. I need a negative 7 there because that would make that 0 out. So I need a negative 7 for x there. So that would be my two solutions to that quadratic equation. So again, I'm looking at this equation again. Notice how again it's quadratic, but again, it's not set equal to 0. So what I need to do is make that 3x 0 out. So I can use a negative 3x here as long as I put a negative 3x here. And since it's a like term with the 17x, I put it underneath there. So then we combine what we can and simplify. So we have x squared. That's going to be plus 14x plus this 49. And that's going to equal then, again, this 0. And since there's no greatest common factor here, all we do is really just see that, hey, let's just set the two sets of parentheses up since the quadratic term is just dead x squared. We know x times x is the only way to get that x squared. But the catch is, what are the factors of 49 that give me this 14? So really what I'm looking at is the factor pairs of 49 that are going to add up to this 14. And I really can't think of a lot of numbers except 7 times 7. And yeah, 7 times 7 does give me 49, and 7 plus 7 is 14. So that text checks out. So I have x plus 7 and x plus 7 is equal to 0. So what you can do is set each one of those equal to 0. So I have x plus 7 equal to 0, and x plus 7 equals 0. And also each one of those would just be negative 7. So really the answer here, there's only one solution, and that's negative 7. But since it occurs twice, sometimes we refer to that as a double root. So if I want to factor this problem, notice how again we see that it is set to equal 0, and it is a quadratic equation because of 3x squared. It is missing the middle term, though. It's missing the linear term. But these two terms do have a 3 in common, I believe. So let's try 192 divided by 3 on the calculator. And that does give me 64. So GCF is 3. So if I pull that 3 out, that gives me x squared minus then this 64 equals then 0. So x squared minus 64 is still factorable. Notice how since there's not a middle term, that means its coefficient was 0. So what I'm basically looking for are the factors of negative 64 to get 0. And really, to get 0, you have to have the same factor each time. So in other words, 64 is the perfect square. That's 8 times 8. And one of them's got to be negative. We also call that the difference of squares. So if the difference of squares, we set up our two sets of parentheses. X times x gives me my x squared, and the negative 8 and the positive 8 give me my negative 64. And when you put the linear terms together, the negative 8x and the 8x are going to zero out. So they're just going to fall out of the problem. So now we just set each one of those factors equal to 0. Notice again, when you set 3 equals 0, that's nonsense. So we drop that out. So x minus 8 equals 0. X plus 8 equals 0. And notice how what minus 8 is 0 would just be 8. So that solution, or that root would be 8. And that would be a negative 8. So the solutions would be an 8 and a negative 8. So look at this equation here. Notice how I changed this question to a different problem. Same kind of concept though, but smaller numbers. Those 42s caused a lot of extra work we didn't want to deal with this time. I did get that from the book, so just make a smaller version of it all. Notice how this is not a quadratic equation at this time. But since it's an equation with the variable on the bottom, we do recognize there's an exclusion. X cannot equal 0. So that's one of the things we pick up on is if you set the denominator equal to 0, what that says is x cannot equal 0. So that's an exclusion here is the number 0. So from here, though, since there is a fraction, we multiply by the least common multiple to get rid of the denominator. And since x is the only denominator, that is my LCM. So I'm going to multiply each side by x to make fractions go away. So remember, we put each side in parentheses and we use multiplication. But on the left side, that's distributive property. So we got to multiply the x to the 6x, which is going to give me, let's see here. That's going to give me 6x squared. X times negative 5 is going to be negative 5x. And on the right-hand side, the x's divide out to leave me 6. So here, we still got to set the equation equal to 0. But we also know that it's quadratic. So that's kind of why we do that. So I put a negative 6 on each side. Since it's quadratic, we want to set it equal to 0. If it was linear, we wouldn't be doing that. We would just be getting x by itself. So we have now 6x squared minus 5x minus 6 is equal to 0. So if I'm going to use big T here and 4 squared, so to factor this, since there is a coefficient of x squared, I like to use 4 squared. So again, the quadratic term goes to the top left. the constant goes to the bottom right. We use big T, but remember, when I use big T, we got to multiply the coefficient of the quadratic term with the constant, and that's what big T becomes. So this 6 here has to multiply to this -6 to make this math work. So this is going to be a -36, but I still got to get a -5. So we're looking for the factors of a -36 that come together to add up to be a -5. So I'm just going to go in order here, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. There's that repeat. So the one that looks like it's got the best chance of getting that 5 is that 4 and 9. Now to get a -36, one of them's got to be negative. But since it's -5, what that's telling me is the -9's got to be negative. So 4 -9 would be my way I build my linear terms. So I'm going to put a 4x here. And again, it doesn't really matter. -9x here. Now the other trick when you do 4 square with a coefficient in front of the x squared, that's 6 there, once I build the inside, when I start building the outside, the first thing I do is find the GCF of the top row. So it looks like they have a 2 and an x in common, so I'm going to factor a 2x out. So then I just start building it. So I have a 2x there, which means I need a 3x there, because 2x times 3x does give me my 6x squared. If I have a 2x there, I just need a 2 over here, because 2x times 2 does give me 4x. To get a -9x, I've got a 3x already, so all I need is a -3. And -3 times 2 does give me this -6. So this factors into then is 3x plus 2 and a 2x minus 3 is equal to 0. So now I just set each factor equal to 0. Kind of needs some room here, so I'm going to make big T go away. He's kind of blocking me a little bit. So get that out of the way. Everything. Okay. So that's a little better. So I'm going to set each factor equal to 0 now. So 3x plus 2 is equal to 0, and 2x minus 3 is equal to 0. Now there's a little bit more going on here. So there's a pattern if you start to play with it. But so notice how the 2 is going to go to their side as a -2. And then you're going to be left now with this 3x equals -2. And then you're going to have to divide both sides by 3. So if I divide each side by 3, so that's going to give me then this x equals -2/3. So notice how if I follow that pattern, the -3 is going to have to go over to their side as a 3, so 2x equals 3. Then the 2 becomes the denominator, x equals 3/2, and I can do that math a little bit quicker just seeing the pattern. So -2/3 and 3/2 would be the solution, and since neither one of those is 0, we can keep both of those answers. So, and factoring this guy here, notice how this is going to be a third degree equation because of the x cubed. We can use factoring by grouping as a start. Also remember, third degree equations can have up to 3 solutions. So remember, if it's 4 or more terms, my first move is to actually put a box around the first 2 and the second 2 and see where that takes me. Now, once we box the first 2 and the second 2, what we do now is find the GCF of each one of those boxes. So the first one, what I'm seeing is there's an x squared in common. It comes out. That leaves me an x and a 4. That looks good. Now, since the front term has a negative in it, we're going to pull it out as well. Let's see if 16 actually goes into 64. So I'm going to try on my calculator, 64 divided by 16. Hopefully it goes into it perfectly. it goes in there 4 times. So I'm actually going to factor out a negative 16 since 16 is the GCF, but let's pull the negative out with it, which means the signs have to change. So it's going to become a positive x. This is going to become then a positive 4. Because remember, this has got to go back through, and it's going to change both of those signs. So once I get it factored to there, notice how they do have a common binomial. That common binomial now gets pulled out in front. So I have an x plus 4 out in front, and I have this x squared minus 16. Now, if you notice, x squared minus 16 is a difference of squares, because 16 is a perfect square because 4 times 4 does give me 16. So what I can do is set up 2 sets of parentheses, and x goes here, and the factors of 16 are that 4 and negative 4. Set negative 4 and 4 go in there, and we're still equal to 0 here. I forgot to do that. Those are all equal to 0 because this is an equation. So I have it factored. So now I have to set each factor equal to 0. X plus 4 is equal to 0. X minus 4 is equal to 0. X plus 4 is equal to 0. So you would have like what, negative 4, 4, and negative 4. So notice how we have 2 different answers, negative 4 and 4. But we have 3 solutions, but 2 of them are the same. So negative 4 and 4 are the only solutions to this problem. Let's see here. Let's go back. Yeah, I've got one more down at the bottom here to do.